Hello guys, in today's video we'll discuss about Shift-Reduce Parser. So in Parser we have two types. Two types of parser we have, top-down parser and bottom-up parser. In bottom-up parser it is again classified into three types. So one is operator precedence parser, next one is Shift-Reduce Parser, and third one is LR. So I'm making the video on LR parsers. So you can check out in my YouTube channel. So in today's topic, we'll discuss about Shift-Reduce Parser. Okay. So in this Shift-Reduce Parser, we have four actions. One is shift, one is reduce, one is accept, the other one is error. So what is shift and what is reduce? Shift means in the predictions in RHS part. In RHS means if there are no handles, means if there are no RHS, suppose A produces B or something B. If these predictions are not there in your stack, this prediction, then we perform shift operation. If suppose A produces C, this element is there in your stack, then we perform reduce operation. Accept means if the string is there and if the string is ending with the dollar, then accept. Error means if you are not able to derive, then we perform error. Okay, so let's see with a example. So let's first take a grammar. So this is our grammar and the input string given is this much, cd. So to calculate Shift-Reduce Parser, these are the heading: stack, input, and action. In stack, top of the stack always starts with a dollar and input always ends with the dollar seed. Now see, these are the predictions, right? These are the right side elements. Are there any RHS elements in this stack? These elements are present in this. Are they present? No, right? No handles. So we need to perform shift. Since no handles means no RHS elements in the stack. So we are performing shift. Shift means what? You need to shift this element here. Okay. C. Now what remaining? D, C, D, dollar. Now this is small c. Okay. Is this small c present in the handle, in the RHS? Is this small c there? No, right? So again shift, because there are no RHS element here in the stack. Are these elements there in this? No, right? So we need to perform shift, since no handles means no RHS elements in the stack. Okay. Now we need to shift this here, C, D. Now remaining elements here. Okay. Now check first element. Is D present in the RHS? Is this D present in the stack? There, right? So if the RHS elements are there in the stack, then you perform reduce. Okay, reduce. By which action we are doing it? Reducing this D from where it is deriving, from this only, right? So C produces D. So for performing reduce action, we need to pop the elements and push. Okay, what we have to pop, because C is deriving this D, so we need to pop this and push this. How will you do that? $C, pop this and push this. This is capital C. So we'll get like this. So remaining elements here, CD, dollar. Okay. Now see, do we have capital C? Do we have capital C here? Single production, as single production you see. We don't have, okay? Next, C. Do we have small c single? We don't have. But we have combinedly small c and capital C. Small c, capital C. So if handles are present in the stack, we need to reduce. Which is deriving this expression. So capital C derives small c, small c. Now you need to pop this. Fully you need to pop and just push this. Okay. Dollar, capital C, CD, dollar. Now check this. Is C present in this? No, right? So if no handles are present, then we need to perform shift. Okay. Shift. What will be shifting? We'll be shifting this here. So dollar, capital C, small c, here D and dollar. Now do we have small c in this single element? We don't have. Do we have capital C and small c? No, right? So if there are no handles, then we perform shift. Since no handles means no RHS in the stack. Okay. So simply shift this here. We get C, small c, shifting this here. Dollar is remained here. Okay. So simply shift this here. I get C, small c, shifting this here. Dollar is remained here. Okay. Now see the next step. Here what do we have? D. Is it present in the RHS? Yes. RHS, this is the RHS element and this is present in the stack. So if the handles are present in the stack, then we perform reduce. This is derived by which expression? This. C produces D. So write this. Capital C produces D. Now pop this and push this. Dollar, capital C and capital C. Dollar will be as it is. Now see, do we have only capital C in the RHS? No. Do we have only small c in the RHS? No. Do we have capital C and small c together? No. But we have small c and capital C. Small c and capital C, which is deriving it. So when there are handles, RHS if there in the stack, then we perform which operation? Reduce. Write that as it is, this one. Small c, capital C. Okay. Now pop this totally. Push this LHS. Capital C. You need to push this. Okay. You need to pop this. You need to push this. What you will push? Capital C. Here dollar as it is. Now see. Do we have only C in the stack? Only in this tag we have C. Do we have it as the right hand element? No, right? So no. Both combinedly we have. See, in this we have combinedly. So we can just, if the handles are present in the stack, then we need to perform reduce. Reduce, from which we are deriving it. S produces capital CC. So while popping, what you need to do? You need to pop this and you need to push this. So finally we get, you need to pop, push this S cap, this is dollar. So when you get starting symbol and dollar in the input symbol, then that is accept. Starting symbol in the stack, in input dollar, then you accept. So this is about Shift-Reduce Parser, and we'll construct a tree for this. Okay. So in order to calculate the parse tree or construct the parse tree, this is bottom up approach, right? So from leaf node to root node you need to come to construct a tree. So what are the input elements? C, D, C, D. In order to calculate parse tree, you calculate it based on the reduce actions. So first reduce action, where we got reduce, capital C produces D. So in place of this D you need to write this, because this is deriving the D, right? So in place of D write capital C. Next reduce action, capital C produces small c, C. So this is derived from this. Okay, so small c and capital C gives capital C. See, C and C, C, C. What you will be deriving? Capital C. So write that. Next reduce, capital C derives D, D. So in place of D you can write capital C. Next capital C derives C, C, small c and C. So this is capital, this is capital. So small c and capital C derives what? Capital C. Okay. Next, in place of capital C you can write as S. You can write as capital C S. So this is the tree. This is the process of tree construction. By taking the reduce actions you can construct this tree from root node, from this leaf node to root node. So this is the star symbol, right? This is root and these are the leaf nodes. Okay, that's all for today. Bye bye.